Welcome to the Empowering Industry Podcast, a production from Empowering Pumps and Equipment as the voice of the pump and related equipment industry. Hey, everybody, and welcome to the Empowering Industry Podcast. This is episode 135, and I'm your host, Charli Matthews. So thanks for joining us, and do us a favor and subscribe, rate and review the podcast so that we show up for other people like you, and just stay connected with us at Empowering Pumps or using that hashtag Empowering Industry Podcast. We will be following along. We are having a big travel season and I'm having so much fun. I've been on the road and I'm continuing to go on the road. So this week, if you're listening to it live when it comes out, we'll be at the Fugitive Emissions Summit, and that will be at Pasadena, Texas at San Jacinto College. I'm really excited to see that event in action and just see that KCI team. They're doing a great job there and putting on many different events. And I was actually recently in Canada and got to spend some time with their team, and they're just so much fun to be around. And so I hope that you get a chance to visit them as well. Next off, of course, is WEFTEC, and we are excited to be there. We will be there all week, and we'll also be there an extra day for Empowering Women in Industries Conference. So Empowering Women 2022, if you want to follow that hashtag. And just if you're at WEFTEC, please look for us. Our empowering team will be there. And, just mention us on social and we'll set up a time where we can connect. So looking forward to seeing you there. Other things that you can do, and I'll put this in the show notes, is just kind of look at what my speaking schedule is, what our trade show schedule is for Empowering Pumps. I did want to mention that our digital magazine went out for September. It's got a lot of great content. And I want to specifically point out our knowledge shared section that is in the magazine, but it's also on our website. And so you can get resources at any time at the website, which is empoweringpumps.com. You can also, get access to our digital edition there. But I'll put all of this in the show notes, and I'll point out one more article as we're talking WEFTEC and the Operations Challenge. I'm really excited about being a partner. We are an awards partner there, and just celebrating the Operations Challenge teams as they compete, and really just enjoy that camaraderie that comes with teams working together for a common mission and goal, and that is to better our industry and make our water safe and reliable and efficient. With little waste. And so I'm really excited about seeing the teams in action, and I hope you will join us. Speaking of WEFTEC, you will love this interview. We are going to be, of course, saying hello to Industrial Flow Solutions, but this industry interview is with Graham Mcivor from Scotland, and he used to work there and kind of came up with this really amazing technology after his. Well, I'm giving away the whole interview if I go on and on, but Graham is the Vice President of Engineering at Industrial Flow Solutions. He's the co-founder and developer of the Deragger technologies. That kind of gives it away of what we're going to be talking about today. But he is bringing intelligent efficiency to the wastewater network, and he has over 10 years of experience working in this sector as a controls engineer at heart, but he's always looking for that best solution. And I think that he has found a really good one for the wastewater industry and our pump manufacturers. Take a look at this interview now. Hey, everybody, and welcome to the Empowering Industry Podcast. I'm your host, Charli Matthews, and I'm really excited about today's guest. We have, many times we're learning about the people within the industry, but this is really a new technology that we're going to go through and some case studies that are really phenomenal, and I'm really interested to learn more. So, Graham, welcome to the podcast, and if you'll just kind of start by introducing yourself for our listeners.
Sure, yeah. Thanks for inviting me on here today. It's really exciting. So I'm Graham Mcivor. I'm the Vice President of Engineering at Industrial Flow Solutions, and I'm one of the original co-founders and developers of the Deragger technology.
Yeah. And so we've heard about a lot of the challenges with raggings and pumps and different things. So I kind of understand why we created this, but can you give us a little background of how you started this and why?
Sure. So back in around 2008, 2009, I used to work for a framework supplier to Scottish Water ID systems. And we were working on a project. Back then I was a controls engineer, and the project was to put remote resets to pumping stations. So what the idea was that in Glasgow, if a pump tripped, they could then press the reset button, bring the pump back in line. When I was doing the project, it kind of occurred to me as to, why are we actually doing this? If a pump trips, there's a good reason for that. And that's when I did some investigation with the customers to understand what the problem, and discovered that, wet wipes cause havoc to the pumps. So dug back into previous jobs that I did as a controls engineer, particularly around variable speed drives and motion control, that I thought, well, if you do analytics on the power, you can actually see and tell what's going on in the shaft of the motor. So you can actually detect when blockages are potentially happening. So did some more research in the marketplace and discovered there wasn't really technology that existed to do this, particularly for the smaller lift stations. So I went away, put together a prototype for that, and we managed to secure one of the worst sites for ragging in Scotland fairly quickly after that. And that was in a place called Burnt Island on the beach. And we installed the deragger at that station where they used to have issues once a day. And they said, well, if you get 50% success, we'll take that as a win. And that station's been in for several years and they didn't have any problems since. So we sort of realized, actually, we could be onto something here.
Yeah, and I think you were. It's what it sounds like. But you had to prove this a little bit, right? You had to.
That was one of our big challenges, because once we'd shown the technology, we fixed that problem. We then went away and the customer said, well, actually, here's some of our problem sites. So we installed the prototype again on several other stations with similar results. And at that point, that's when we realized, well, we need to move from a prototype stage to a full production unit. And that's when the Deragger 2 product came out. And we developed the Deragger 2 product shortly after that, made it such a small, compact unit. It's about 4 inches tall, 1 inch wide, and got some more sites and got some more success within Scottish Water. But it was quite small scale at that point. We were really kind of struggling to make it a lot more mainstream. And I think part of that was down to being a pain point solution. So we kind of ran out of the really problematic sites. And that's where we then had to do a lot more work in trying to prove the technology. And that's when we then went to WRC, which is the Water Research Council in the UK. And we wanted to actually do an evaluation, because you can tell the customers or show the customers how it works, but unless you get third-party verification, it makes it incredibly difficult for customers to understand the benefits until they get some independent evaluation.
Yeah, and so this started there in Scotland, and what you're doing there, how did it get to the US? What was that process like?
So after the success at our first site, funnily enough, we got a magazine journal, did an article on us for Scottish Water, and a gentleman called Mark Pettit, one of the engineers in Los Angeles County Sanitation District, he read the article and kind of went, wow, this is exactly the problem I have. So he called up Scottish Water and said, hey, how do we get a shot at this technology, because we have the same issue. So eventually I got a phone call out the blue from Mark saying, hey, I'm from California, I'm wanting to put some of your units in. And at this stage, we were still in the process between the Deragger 1 prototype and the Deragger 2. So we're kind of like, well, we're not quite there yet, but we're just about. So I agreed that in 3 months I was going to be through in Boston. So I said, well, actually, when I'm in Boston, I'll fly over to California, I'll have a look at your station, try and work out a plan, how we can help you, how we can work out importation, UL certification, all this kind of stuff. That was all incredibly new to us as a small business at the time. So yeah, it was quite exciting. And from there, we finished off the Deragger 2 technology. We then got the unit. We've got a local service partner who Mark introduced us to, who does all their kind of control stuff, and we got it installed in that first station. And from there, it was kind of, well, there's a market now in the US. So yeah.
There's a big market. I think people are flushing these wipes without thinking for sure over here. But one thing, just let's talk a little bit, and maybe some people are familiar with this and maybe others aren't, but tell us a little bit about that problem and like, what does the technology do? Like, can you go into that a little deeper?
Yeah, sure. So one of the big challenges that's faced with a lot of countries around the world is particularly in Europe as well, where we have a lot more antiquated sewer networks, that people are flushing non-organics down the toilet. So instead of it just being the 3 Ps, we call it over here, people are flushing down wet wipes, and the kind of explosion of wet wipe use, or even what's the word for it? The toilet cleaning wipes that people use for cleaning toilets, and Swiffer cloths and stuff like that end up down the drain.
Yes, I've even heard like T-shirts and things like that also.
Yeah, you get everything. You get anything that can go down the drain ends up down the drain. But the big problem with wet wipes themselves is that, unlike toilet paper, they don't break down in the waste stream. So these basically cloth wipes stay whole and make their way into the pumping station. When the pumps pump the wipes, most pumps will deliver and pass the wipes forward. A lot of them are designed specifically to do that, but maybe 9 out of 10 of the wipes will pass through the pump without any problem. But as soon as that one wipe sticks on that impeller the wrong way, it then creates a frictionless surface for all the other wipes to then pile on top of it. And then what happens is the rotating action of the impeller knits the wipes together and actually creates this kind of mop head looking thing inside the pump. And that just gets bigger and bigger and bigger until eventually the pump grinds to a halt and trips out. And that then requires manual intervention to then go lift the pump, pull it apart, and pull the rag ball out.
Yes. And so the technology, as I understand it, can let you know when that's happening.
Yeah. So our technology is very unique, that we detect when that first wipe catches on the impeller. So by looking at the way that the power signature changes for when that exact wipe catches, it allows us to differentiate between things like, if a ball of grease hits the impeller, so some technologies that are out there in the marketplace might just say, well, that's an increase in load, do a clean, but it's a ball of grease hitting the impeller and passing on has a different characteristic to a wipe catching and then dragging. So there's very different subtle differences to the characteristics of the power, and that's what our technology detects, stops the pump, does a reversal to just agitate the impeller to free off the wipe and then go back in the forward direction and pass the wipe forward. And the benefit of doing that is you're not chopping it up. So you're not installing grinders or chopper pumps or that kind of stuff. We're using the existing pump, detecting when that initial wipe, stopping the pump, doing the reversal, and then going back forward just to pass it forward.
Yes. And, as you're reversing the pump, there was concern about the impeller spinning off. Makes sense. You have to turn it one way to get it on there. So that's not the case. But you had to prove that, right?
Yeah. And that was quite a lot of the help that WRC did in that, and also Scottish Water, that there was quite a misconception of running pumps in reverse. But I mean, I've personally spoken to customers before that have had pumps installed for 6 months, and they might have actually been, oh yeah, we actually hooked that pump up wrong and they were running it in reverse for the last 6 months, just because it's quite easy to do that. But what the work we did with WRC was they went out and also spoke with some pump manufacturers. We also worked closely with a lot of pump manufacturers back a few years ago doing cloggability studies. And, as long as your impeller's keyed, or if it's a taper lock, we're not allowing that mass to build up. So when we go in reverse, we're putting the same load on the impeller as we do in the normal forward direction. So I think one of the misconceptions is people maybe, once the pump's locked, trying to then reverse it on that's when you can start doing damage to your keyways or shafts.
Okay. And then kind of the way that you're reading that this white has caught on, you're looking at the power consumption, you're looking at what are some of those other factors that you can identify?
So yeah, if you're we look at the real time power. So we're analyzing what the pump is consuming at that exact point, and depending on how the power changes depends on if it's a rag or if it's a rock that it's impeller. So that's what we're looking at predominantly for our anti-ragging part. But because we're doing all of this analytics, we also can start to look at the longer term impact of the motor. So by analyzing the power, but looking at that over a course of multiple days as well, we can start to look at more of the condition monitoring side of stuff. So because we can essentially say, well, your pump's not ragged, but you're starting to get slow efficiency degradation over time, that's not due to rags, that's due to impeller wear, or it could be that your bearings are starting to go, or other factors are impacting your pump's performance, and it's not down to the wipes.
Right. So how is it installed? Like, how do you get that information? Is it hard? Is it like, does it tie on to, tell me a little bit more about how you
So
actually.
it's a small electronic device. So it's, as I said earlier, it's 1 inch wide by 4 inches tall, and it clips inside your control panel. And we have our own current sensors that clip around the leads to the motor. We take the raw up to 600 volts onto our device as well. So we take, we're looking at the voltage, the current, the frequency, and we have a power analytics chip inside our device as well that then does all the power analytics. And then we have a microcontroller in there as well that does the logic for, detecting when the blockage is there, and also doing the control of the motor. So we do have to interface with the existing starter, whether that's across the line or a VFD. Our product doesn't matter what starter is. It doesn't matter what pump type it is. It doesn't matter the starter. And that's one of the other sort of key parts of our technology, is that we wanted to make it pump agnostic as possible and starter agnostic, so that we're not forcing you that you must use this pump type or you must use this starter type. We said, well, actually, how about making a solution that's flexible across all pumps and all control types as well? And that was,
Yeah, I think that's awesome. Yeah, because then you're using your existing equipment, just kind of adding on to that, and solving that problem that way.
Yeah.
So we've talked a little bit about kind of the other benefits that using this would have on your system. Is there how do people like integrate this into their system? Do they already have kind of that, have to have that integrated SCADA system, or
No.
is it really across the board?
It is. We designed our system incredibly modular. So the way that we wanted to look at it is that if you have different pumping applications like dry pit, wet pit, RAS pumps, WAS pumps, or even surface aeration, etc., we wanted to say, right, how can we design a product that can go on each of these pump types? So it's not pump agnostic. We can go in any control panel that we wish. But some customers simply just have a control panel with a start-stop. Other customers have a control panel that has a telemetry outstation that they maybe take 16 to 20 signals back. But then we have other customers that have full-blown SCADA systems where they're taking multiple signals back at a much higher rate. So part of when we had our technology is we said, well, let's make the product so in its most base form, you can clip the device into a really simplistic panel and it will just do the anti-ragging. But then we also identified that there's customers that might want access to that data in different ways. So we put then communications onto our device so that they can have it as a single standalone station that it just works automatically and nobody needs to intervene with it, or we can clip the system in and integrate it full-blown to SCADA. Our technology has also evolved on through our advanced Keypad, which brings multiple layers of communication onto that as well. So our advanced Keypad is a Microsoft Azure certified device. So as well as providing, having the basic standalone module, if you put an advanced keypad on there, you can get the full SCADA integration, you can get the full IoT connectivity to it as well. So we can then integrate with Microsoft Azure platforms so that the data that we harvest, which is incredibly valuable to our customers, they can then use that in their desired ways.
Yeah, I think it's remarkable. And I know that we've talked about this problem so long and, how are we going to conquer this clog? And this seems like a way that we can do that and really use existing equipment. So I love that. And I also love that you are kind of an entrepreneur in this space that kind of saw a problem and really said, okay, well, let's dive into the technology and figure this out. So let me shift gears just a little bit and talk about, your involvement in this and kind of bringing this into the market. I'm just curious how you got in the industry yourself and.
Yeah, it's been an exciting journey because I went from controls engineer, identifying a problem, then having that fork in the road of, do I want to stay as an engineer or do I actually want to go get funding and then take this product to market and launch a product and grow a business? And I was really grateful that the Scottish government has a really good program. It's called Scottish Enterprise, and they identify businesses that have got high growth potential. And we were lucky enough to get, sort of mentored by them and got support by them. And they take small businesses and put them through, leadership courses or marketing courses and finance courses and really support businesses, not just through funding, but also through development of the staff. So they were really supportive to myself and to the team to actually, really push exports. That's what they're set up for doing. It's how can Scotland as a country grow, but how can we support our companies to grow exports? And luckily enough, the driver was at that time very much on exports. How can the country grow exports? And we were an export business to the US. Most of our customers started to become in the US. So therefore, I was lucky enough to go to MIT to do the entrepreneurial development program there, which was an absolute fantastic course. And it really gave me the skills of going from engineer to then going to business leader and getting all the skills in a very short crash course of how to run a business, how to grow, how to get investment, how to look at marketing, how to grow your rep network, how to do all of that stuff, as well as gaining a lot of contacts in both the US and in Europe to help grow the business as well. So yes, it's been an exciting 10 years.
Absolutely. And, as an entrepreneur, I'm just well done. I just want to say, I know it's a journey and just really glad for Industrial Flow Solutions too, that they've got to work with you and bring this technology to the US. And I think it's definitely needed and it sounds like not in there, I know just enough about a pump to be dangerous. I like to say, don't be working on them, but this sounds like a solution that can really help many manufacturers and utilities because you can plug it into their existing systems.
Yeah, and that's what was really drew us to Industrial Flow Solutions as well, is that our alignment and vision was very similar. And when we started Clearwater Controls, we actually kind of laughed shortly after it was formed and said, it would have been really great if we'd actually just developed our own pump. Because, we were getting a lot of pushback on, you can't reverse pumps, or, this is not going to work with our pump and all this kind of stuff. So to actually now have a pump manufacturer on the same side as us, it certainly allows us to put forward a much better solution, to be able to say, well, actually, if your pump, for some reason, if that pump doesn't want to reverse, then we can provide you with a pump and a solution that can. They've also got some awesome technology in their Overwatch system, which is their direct and line pumping system. And the technology that Clearwater can bring to that through our Deragger Pro pump station controller, that takes the mechanical element of this new technology, but then overlays the Clearwater technology with the connectivity and the pump control, which then brings that into a new league as well. And really, that makes a really good fit as a business and how we can work together.
Absolutely. Well, like I said, I think it's wonderful, and I think that it was a testament to all the work and the testing that had to be done, and the proof and evidence that you had to give our manufacturing community. But it sounds like you did that, and you've got one on board that supports you, and so wonderful all around. Is there anything else that you want to leave our listeners with before we jump off here?
Let me see. So yeah, I think. As I said, I think one of the things that surprised us so much when we went through this whole journey is that customers don't always know the extent of the problem because a lot of the lift stations are not monitored on a real-time basis. That the stations that are the problematic ones are the ones that they're there all the time. But one of the things that we've learned, particularly through the data that we've been gathering, is that sometimes that pump station that maybe just gives you bother once every 6 months, it might not just be that one day in the 6 months it's giving you bother for. It's actually more than likely that when you arrive on site, clean the pump, put it back in the pit, it then starts to slowly grind, away with rags, and it might take a 6-month period to actually get to the point where you're aware of the issue. And there's a lot of lift stations out there that have that issue, that they start off performing great after maintenance, but then 6 months down the line, the pump could be running 24/7 because it's just not keeping up with the flow. Whereas if you actually keep your pumps clean and rag free, your station efficiency improves massively. But not just that, the wear and tear that you're putting on the pumps by grinding on through with rags inside your pump, you've got all that excess vibration, you've got the excess power consumption, you're drawing more current, which is damaging your windings, that you're actually just making your pumps not last anywhere near as long as they should do. So you're replacing your pumps more often, you're having to do maintenance on your pumps from an overhaul point of view more often. But by keeping the pumps clean, your system runs more efficiently, you save energy, but you're not spending as much capital money on new pumps as often, which my pump sales colleagues won't particularly like me saying that, but it's one of those things that if you can keep your pumps running efficiently and on curve, then they're going to last a lot longer.
Yeah, and we love to have more energy efficiency, less energy consumption, less waste, and we can create new things and sell pumps that way versus trying to fix that same broken pump. That is just a struggle that I know is real for a lot of operators out there. So definitely helping them have that peace of mind and can sleep at night for sure.
Yeah, and it also brings about reliability, because when your pump's running ragged up, when you get that first storm event, particularly when you get a lot of combined sewers, it's when that rain event happens, that's when all your pumps start ragging up worse. And you get the one rain event, and next minute you have 10, 20 lift stations all blocked at one time. So if you can keep them all running efficiently and clean, when that deluge comes in, you've got a much better chance of being able to cope with the rags as they come in the well.
Right, because the damage that can be created from something like that is extensive outside of the pump system at that point when we back things up. And that leads to, sanitation issues and everything else. So, so many different ways that this is a benefit for our listeners. And I just want to thank you, Graham, for bringing this technology to us and
Sure.
Taking those risks and doing the work. I want to thank Industrial Flow Solutions. They're a great partner of ours, and I'm happy to be able to, promote this and send it out to our audience and our community.
Cool. No problem. Thanks for your time.
That brings us to the end of the show. So thanks for listening, everybody. Do us a favor, rate and review the podcast so that it shows up for everyone else. Also, like I said earlier, just mention us at Empowering Pumps or using that hashtag Empowering Industry Podcast. We'd love to stay in touch with you. You can email us at podcast@Empowering Pumps. And, we're really excited about this trade show season and moving into the next year. We will be having, many different I guess, changes because of, the new year coming. And so just stay tuned for the next episode. I'll kind of go into that then. And just really, until next time, stay empowering or be empowering. I think I just changed up and gave myself a new ending there. So until next time, be empowering.